And here we go with systems of inequalities. Now in this first video we're going to look at a system of, can you see, linear inequalities. These are both linear graphs. There's no squares, no absolute values, nothing else weird going on. It's just x and y. So it's going to be a linear graph. Note that with systems of inequalities, back when we did systems of equations, we could do graphing, substitution, elimination. With a inequality, remember, we have to shade half of the graph. There's no way to represent that algebraically. And so therefore, we won't be able to do this by substitution or elimination. We can only do it by graphing. So remember when we did graphing a system, the first thing we did was we graphed the first equation. So that's what we're going to do. We'll just take equation number 1 right here, and we're going to graph it. So we're going to pretend for a moment that this is just y equals mx plus b so that we can draw the line. This is the division line between the solutions and the non-solutions. So since it's in the right format already, I just put my y-intercept of 3. And then I go ahead and do my slope, which is -2/1. You should be comfortable with this by now. If you're not, you should probably go back and watch a couple of videos on how to graph using slope-intercept form. All right, so then we go up and over, go back the other way. Note that from left to right, as I go left to right, my graph is going down. That's my negative slope. All right, now at this point I'm ready to draw the line, but remember with inequalities, I need to recognize whether the line is a solution or not. When I draw a solid line, I'm saying, you know what, the points on this line are solutions. They make this statement true. In this case, I don't want the two sides to be equal. They can only be less than. And so I can't draw a solid line. What I'm going to do instead is draw a nice little dashed line there. And it's going to take a little while, so I'm just going to sing along. If you ever seen Muppets, that the chef guy, it kind of sounds like him, right? Anyway, let's go. So we got our line there, and then the other thing with inequalities is we need to shade it, right? So in this case, it says y is less than, which means it's probably a pretty good guess to shade down below, because that's where all the small y values are. The big y values are up here. But what I'm going to do is I'm going to go ahead and just test out a point anyway. I like 0, 0 because zeros are nice. It's not on the line, so I can do that. So I go 0 is less than -2 times 0 plus 3. And that gives me 0 is less than 3, which is true. So I need to make sure to include that. And so there we go. There's my first system. My first equation. Now I'm going to go ahead, I'm going to draw the other one. So that's the 3x minus 5y is greater than or equal to 10. Now this is not in y equals mx plus b, so the next thing I got to do is rearrange a little bit. So I'm going to subtract the 3x. I got to get y all by itself. Got to get. -5y is greater than or equal to. Now you could go 10 minus 3x. I prefer having the 3x in front. And it was a positive 10. Don't switch up the signs. If you change the order, that's fine, but you got to keep the minus with the 3x, and the 10 is positive, so it's got to stay plus. It's got to stay positive. Then I'm going to divide by -5. Now remember, when you divide, you need to flip the sign if you divide by a negative, which is what I just did. So I do need to flip the sign. Okay? And then it'll be -3 over -5, which will be a positive 3 over 5x. And then I also need to divide the 10 by -5. Don't forget, you've got to divide both of them because these are in their own little world up there. If you divide, you got to distribute that division. And you got to divide both of them. All right, so then I go 10 divided by -5, which is -2. I'm ready to graph. Now, some of you may have noticed that the sign flipped around. You know what? That's okay because I divided by a negative. I expect that. So now I'm going to go 3/5 x minus 2. So I'm going to go to -2. That's my y-intercept there. And I'm going to go up 3, 1, 2, 3, over 1, 2, 3, 4, 5. I ran out of space, so let's go down 3, over 1, 2, 3, 4, 5. Just to double check, note that I had a positive slope, and going from left to right, my points are going up. So now I'm ready to draw the line. And here we go. Whoa, it looks like, sorry, I made a mistake there. I went down 4, didn't I? So I need to go down 3 and over 1, 2, 3, 4, 5. There we go. Sorry about that. You probably caught that before I did. And then we draw the line. Notice that I drew it solid this time. Why did I draw it solid? Well, I drew it solid because this time it's greater than or equal to, which means that or means we want to include the points where it's equal, which is what the line represents, the points where those two sides are equal. So we got that. Now again, I've got this less than, which means I'm probably shading down below, but let's go ahead and test out a point. When I test out a point, I always test in the original function. Why? Because if I made a mistake here, down here, and if I forgot to flip the sign or something, that will fix the problem for me. Because then I'll have 3 times 0 minus 5 times 0 is greater than or equal to 10, which is 0 is greater than or equal to 10, which is not true, so I want to shade away from 0, 0, which, as we already stated, means we go down this way. So that's all my work. Now, you may notice that they don't really cross at a nice point. That's not important, because the answer here, there's not just one answer. It's not just the one on that point. We want to mark anything that works in both of those equations at the same time, which is a whole bunch of answers. Note that I've got both red and green in this little quadrant right here. All of those are my answers, because any point in that region will work in both of those situations. And so I'm actually going to do this a little bit darker so that I show that I understand that everything in here is an answer. Now note that anything on the red line will not be an answer, but anything on the green line will be, as well as anything within this dark boundary. Here, let's check. Let's test it out. Let's take 0, negative 5. That's a point right in the middle there, so let's test it out. We'll put it in both of them. So if I put it into the first one, I'll have negative 5. So I'm testing out 0, negative 5. Negative 5 is less than negative 2 times 0 plus 3. And then if I work that out, I get negative 5 is less than 3, which is true. We'll try it in the other one as well. So I'll go 3 times 0 minus 5 times negative 5 is greater than or equal to 10. 3 times 0 is 0. Negative 5 times negative 5 is positive 25, which is definitely greater than 10. It works there. I've checked my answer. Therefore, anything in this shaded region works in both equations. Okay, just like when we were looking for a system of equations, the crossing point was the only place where both of them worked. Here, anywhere where they both are shaded is also a solution. Note that the points on the green line, as I stated before, do work in both, because it's on the green line, so it works in the green one. It's in the red shaded area, so it works in that as well. These points over here would not be solutions, though these are. All right, well, that's the first video on inequalities. If you'll go to the second one, I'll show you a system of a quadratic and a linear. What?